All right, let's do a little introduction into our next topic, confidence intervals. It's going to be closely related to the previous topic of sampling distributions. So we're going to be mostly looking at proportions here. And so remember that every time we take a sample, we're going to be asking random people, or we're going to be looking at random things. The sample proportion, which we often call p hat, this sample proportion is a random variable. Okay, it's random. We don't know what it is. Every time we take a sample, p hat is going to be different. Now, it's usually going to be pretty similar, right? As long as our sample size is big enough, this p hat, this sample proportion, should be pretty close to the true population parameter, our proportion of p. Right? So in general, we talked about sampling distributions last time. P hat, every time we take a sample, is going to kind of bounce around, but hopefully it should be mostly near P. And if we have a couple conditions, randomization, independence, sample size conditions, P hat will be bouncing around with a normal distribution. So in this section, we're going to talk about, well, how close or how good of an estimate, what's another way of estimating, and how good of an estimate is it for that true population proportion? That's what confidence intervals are all about. So let's start by remembering the standard error. So the standard error is the standard deviation for the sampling distribution. Okay, so when specifically we were looking at proportions, you can calculate it this way. When we were looking at sampling distributions of means, it would just be the true population standard deviation, sigma, divided by the square root of n. Well, here we're going to use this estimate of the standard deviation by estimating the standard deviation with the square root of p hat q hat. Okay, this is usually pretty close, or well, it's a good estimate for the standard deviation, right? So if we find the true standard error with sigma divided by the square root of n, well, this is up top. The square root of p hat q hat is going to be our estimation for that sigma. Okay, so let's say we don't know p and we don't know sigma. This is how we're going to approximate the standard error, the standard deviation of the sampling distribution. So let's do an example to kind of introduce this topic of confidence intervals. So someone took a survey of 2,500 HR professionals, okay? And this survey showed that about 1,200 of those used social networking sites to research job applicants. Kind of an interesting result in and of itself. State the sample proportion and calculate the standard error for the sample proportion. Remember, sample proportion, that's our p hat. P hat and x bar, those are usually the sampling things that we're looking at. X bar is for sample mean. P hat is for sample proportion. This is also what's known as a point estimate. We are estimating the, let's write that down. Point estimate. We are estimating the actual proportion P. We're estimating the actual proportion of HR professionals who use social networking sites to research job applicants. All right. And we're estimating it with a single point. And that single point is at p hat. So p hat is going to say, well, 1,200 out of 2,500 used it. What's this fraction? Is this 48%? I think it's 0.48, but I'm going to use a calculator because I don't want to make an error this early in the video. 1,200 divided by 2,500 is indeed, we are way too zoomed in here, 0.48. Great. So that's our p hat. We stated the sample proportion. It's right here. And calculate the standard error. Well, right here, we said the standard error of p hat the standard deviation of the sampling distribution. P hat is a random variable. What is its distribution? What is its standard deviation? Is going to be the square root of P hat Q hat over N. Well, what's P hat? We just said it was 48%. Q hat, remember that Q in general is 1 minus P. It's the same for Q hat. That's going to be 52%. Divided by our sample size, 2,500. Let's type that into a calculator. Be very careful with your parentheses here. We have the square root of 0.48 times 0.52 divided by n, 2,500. That's going to be actually really, really close to 1%, really, really close to 0.01. We'll have a couple digits afterwards if you want more precision, but it's about 0.01. That's our standard error right here. And we've answered the question. Let's do part B. Draw how the sampling distribution for P hat should look. Now remember that as long as we have a couple requirements, independence, randomization, and sample size, we should have about at least 10 successes and 10 failures. P corresponds to successes. We have all of these. If we have that, then P hat, the distribution, should be normally distributed with mean of P, which we don't know. We're going to approximate it with P hat. All right. And standard error, about 0.01. So it should look, and again, this is an estimate for P. We don't actually know where P is. In this case, it should look like a normal distribution. The mean be 0.48. And then 1 standard deviation, 2 standard deviations away, 3 standard deviations. Again, look for that curve, that inflection point. That's where 1 standard deviation is. That's going to be about 0.49, 0.50, and 0.51. And vice versa. Well, not vice versa, but in the other direction as well. 0.47, 0.46, 0.45. So this is normally distributed, which means we can use the empirical rule, right? About 68% of the data, about 68% of these samples, if we took a bunch of different samples of a bunch of different HR professionals with this sample size, about 68% of them would have the result of 47 to 49% using social networking sites for job applicants. Similarly, right, within 2 standard deviations of the mean, if we did a whole bunch of these, then about 95% of these surveys would show between 46% and 50% HR professionals using social networking sites to research job applications. So this is what it's looking for right now. Okay. Oh, I jumped the gun. Based on the empirical rule, the 68, 95, 99.7% rule, where do you expect 95% to fall? Well, it's normally distributed, so we're going to answer within 2 standard deviations of the mean. Or in other words, between 46% and 50% of HR professionals using social networking sites, etc. Dot, dot, dot. All right. Let's look at another example. Between what two proportions do we capture exactly 95% of values? My cat is over there making a ruckus, and she knows I'm not going to interrupt myself during a video to stop her. You better behave, October. This video is getting close to being done. All right, so this was approximately, we're curious about the interval that does exactly these ones. Oops. Let's not jump the gun. This is asking for the middle 95% of data. It's tying into the previous units. Remember before we found middle 50%, middle 60%, middle 70%, etc., right? Now, how do we find the middle 95%? Well, the middle 95% is going to have 5% outside of that. Or in other words, 2.5% on the right, 2.5% on the left. How many standard deviations away is that? Well, we can use GeoGebra, right? When are we above 2.5% of the data? We're above 2.5% of the data, the 2.5th percentile, when we're 1.96 standard deviations below the mean. Okay, this right here is 1.96 standard deviations below the mean. And since the standard normal curve is symmetric, this right here says when we're 1.96 standard deviations above the mean. So it wants this interval. Well, what's a standard deviation here? In our example, the standard deviation is about 0.01. So what is 1.96 standard deviations below the mean? Let's calculate it. 1.96 standard deviations below the mean means take the mean, subtract 1.96 standard deviations from the mean. Here, take the mean and add 1.96 standard deviations of the mean. And when you do find these two intervals, you're going to get, well, I can't do this in my head either, 0.48 minus 1.96 standard deviations away from the mean is 46.04%. Wait, I already forgot. 4604, right? And likewise, 1.96 standard deviations above the mean, 49.96. This is actually a confidence interval. It's estimating the true population proportion, right? 95% of these sample proportions are going to be in this interval. Well, if 95% of the proportions are in this interval, it essentially means that we have a 95% chance that this interval contains the true proportion. Okay, but we'll talk more about that later, but that's kind of what's going on here. So to find a confidence interval, and again, we'll talk more in the next video about what a confidence interval is exactly. This is just introducing things. But to find a confidence interval, what we're going to do is look at the sample proportion. Sample proportion, right, is p hat. And we're going to add and subtract the margin of error. That's just going to be the, we're adding, the margin of error is just how far do we have to go in either direction? to get a certain percent of the data. Okay, so this right here is in our last example, right? That's going to be the 1.96 standard deviations for a 95% confidence. But again, we'll unpack these terms a little bit more later. This is how we calculate it. This is exactly what we did in the last example, right? In the last example, we said 0.48. It was plus or minus because we had one of each. In the last example, our z-star was 1.96. And then that standard error was 0.01. You can see the correlation with this definition and what we accidentally used. It wasn't an accident. But this creates an interval of possible values for the true value of the population proportion. This is the thing that we really care about. So p hat gives us a point estimate. It gives us an estimate of the actual population proportion at a single point. This gives us an interval. It's an interval estimate. Okay. Confidence intervals are just another way of estimating the true value. They're called interval estimates. All right. This critical z-score, that's that 1.96. And that's how many standard deviations away from the mean do we have to be to get 95% of the data? And it's close to 2, right? Empirical rule says that within 2 standard deviations is about 95%. Well, it turns out if we want exactly 95%, it's 1.96 standard deviations away from the mean. All right. If you're curious about different confidence levels, 90%, 80%, you're going to have a different z-star. Okay. So it is dependent on that confidence level. What we call the margin of error, that is what we're adding and subtracting. That's how far do we go to either side of that p hat. Okay. So to kind of summarize, confidence intervals estimate p. Okay. Confidence intervals estimate p. Just like p hat. They're both ways of estimating p. P hat is estimating it with a point from a single sample, and a constant confidence interval estimates that true population proportion with an interval. So here, in this last one, we're estimating with 95% confidence that the true percentage of HR professionals that use social networking sites to research job applicants is between 46% and 50%. Because of our sample size, we're 95% confident that that's the case. Again, we'll talk more about this conceptually in the next video, but this is a nice little introduction.